Hi there, guys. Ever since 2017, the way we approach the standard normal distribution has changed when they changed the A level. Now, and one of the reasons we changed the approach is because the ClassWiz calculator is now far better than what we used to have. We used to have tables, we don't really have those anymore. We just have the calculator, so we've changed it. Now, I'm going to give you an understanding in this video of what we mean by the standard normal distribution, why it's useful, and in the next video, we're going to really use it to its potential, but you have to wait and see. No spoiler alerts here. So let's have a look at this question. So we're told this random variable x is distributed normally with a mean of 16 and a standard deviation of 2. So with any question, you must always start by sketching your distribution. So I'm just going to pop on a 16 here. If I wanted to, because I know the standard deviation is 2, if I go to one standard deviation above, 2, and then I'm going to pop that one there. I'll try and do that as neat as possible on the side. 14, 12, 10. So the lines I'm drawing here are representing one standard deviation above and below. Now notice if we look over to the right here, we've got a Z. Now we always use Z to represent the standard normal. So please don't use a Z in any context when you're letting certain letters represent the random variables, because it was always used for standard normal. And you'll notice the mean is always 0 and the standard deviation is always 1, and that is particularly useful at times. So what I can do is now draw a standard normal distribution. So it's exactly the same curve, but it would be a Z. I'm trying to get that in exactly the same line, and that's going to be 0. So that is my mean value. Originally for the data is 16, but when we're looking at standardized, it is 0. And I'm just going to, it's a bad drawing. It's a bad drawing because this gap here, I wanted that really to be really low. So I'm going to put a 1, 2, and a 3 here, -1, -2, and a -3. And what these numbers are representing is how many standard deviations there that the values I get here are above the mean. So, for example, if we take 18, there is a formula to work out how many standard deviations it is above the mean. So the Z value that would tell us that information is equal to the score, the observed value, minus the mean for this distribution up here, and divided by the standard deviation. So if we take 18, we know it's one standard deviation because we can see it in the data, but I'm going to show you how we can get one. So if we take 18, take away the mean, which was 16, divided by the standard deviation, which is 2, you can see that equals 1. That tells me 18 is one standard deviation. But if we just change color, let's say we had something like 19. Let's do 19. So let's go for 19. And we're interested to know how many standard deviations above the mean is that? Well, we could type this in. So we just go, let's put it down here. So Z equals 19 minus 16 over 2. So that's 3 over 2, which is 1.5. So it's 1.5 standard deviations above the mean. If we got a result out, let's just change color again, something like here, and that result was minus 0.872, that would mean the corresponding value up here is minus 0.872 standard deviations below the mean. Okay, that's what's useful. So let's have a look at this question. So in here we've got a distribution for x. It's distributed normally, mean of 12, standard deviation of 3, and we're asked what is the corresponding value of the standardized normal. So basically, for these observed values here and here, how many standard deviations above or below the mean are they? So we're going to draw first distribution, x, our second distribution, z. Here we have 12, and the question is 8. Okay, that's our observed value. So how many standard deviations above and below is this? So this is 0, and that's what we're going to work out here. Right, so Right. So if I was to look at the standard deviations, I know it's 3 from up here. So if I go 3 down, I get to 9. If I go another 3 down, I get to 6. So I'm expecting this value to be just below 1 standard deviation below the mean. So let's work it out. So my z value is equal to my observed value minus the mean, which was 12, over my standard deviation, which is 3. And that equals minus 4/3 or minus 1.3 recurring standard deviations below the mean. We do the same with this one. I'm just going to draw these two again. Oh, did that in a really weird place. So that's 12. One standard deviation we'd know would be 15. So we are looking at this value here of 13. So how many standard deviations will that be? That's 13. So, sorry, z, x. So z is equal to the observed value of 13, take away the mean, divided by the standard deviation, and you get 1/3. So 13 is 1/3 of a standard deviation above the mean. One more. So this is a little bit more complex now. We begin to use our calculators. So this time we're told a standardized normal distribution. So let's just draw a picture real quick. So the mean is 0, and it's saying, well, what is this value here? What could it be? So we get a probability of 0.3. Now, you should remember the probability always adds up to 1. So this is set up for cumulative drawing, so this is much easier than this blue one over here. So I know if I was to include all the way up to the mean, that would be half. So it must be something like this. So this is 0.3. So what could this be? So what we're going to do is pick up our calculators and press menu and then go down to 7, which is a picture of what I've just drawn. And we're going to look at the inverse normal. So this time area is 0.3, but you can see your calculator should default automatically to the standard normal distribution. So the standard deviation is put in as 1 and the mean is 0. So press equals, and we get this value here to be minus 0.524. And that means that to get a probability of 0.3, this value A is minus 0.5244 standard deviations below the mean. We do this one. Now it's greater than this value, and that's 0.6. So we're going to be looking to the right hand side of wherever we put this next line. So it has to be to the left of the mean, because all of this would be 0.6. So the probability of getting a score greater than A is 0.6. What is that score? Well, all the distributions, the cumulative ones, are set up for accumulation, so from the left to right. So if that's 0.6, what I'm going to be putting in to my area is 0.4. So press equals again, 0.4, and I get A to be minus 0.2533 standard deviations below the mean. Now, one more thing, I've never seen this in exam, I've never used it, it features in the book, I thought I might mention it. But if they ever ask you to write in this form, you just need to know this is the same thing. So this here is the same as saying the probability of a standard normal is less than 0.75. So you can see the numbers are the same, but instead of writing probability of standard normal is less than, just write the symbol. I can't see the point in it myself, but it's just worth knowing about. Now, one more question we're going to do, a wordy one. So the systolic blood pressure of an adult population, S, is modeled by a normal distribution. So it's good practice now to say let S be the random variable, systolic pressure. I'll do that now. And S is distributed normally, and we can see here we've got a mean and a standard deviation, 127 and 16 squared. Don't forget the squared, it's really important. A medical researcher wants to study adults with blood pressure higher than the 95th percentile. Now, this is an example out of the book, but the book is doing it in such a weird way that using a table that you're not going to be given. So we've got S. We know this is 127, but we're only interested in the 95th percentile and higher. So that's going to be somewhere up here. So this is going to be 0.05. So we can use our calculators. We're going to use the inverse normal again. Sorry, press the wrong one. So 7. So inverse normal. Area is going to be 0.05. Everything should be remembered, like the standard deviation. So standard deviation is 16 and the mean is 127. So I could have done this standard normal to work this out. I just don't see the point. It's just more work when I can just use this bit of data I have here. Now, why can't I put 0.95 in? Because it's set up for cumulative. So I've got to put, sorry, I can't put 0.05 in. I'm going to be having to put in this area here to get this figure. So 0.95, 16 and 127. And that value there is 153.3177. That's to 4 dp. All right, so that is the minimum blood pressure for an adult included in a study. Anything over that is in the 95th percentile. Right, guys, I really hope that makes sense. Sorry for stumbling a bit on the end there, but it's nearly midnight and I'm knackered. Good luck.